So here is another question on conditions for solvability of linear equations in two variables. So it is given, find the value of k for which the following system of equations has infinitely many solutions. The two equations are 2x minus 3y is equal to 7 and k plus 1x plus 1 minus 2ky is equal to 5k minus 4. So first we have to write the equations in their standard form, that is 2x minus 3y minus 7 is equal to 0 and k plus 1 x plus 1 minus 2ky minus 5k minus 4, that's why I've given the bracket, that is equal to 0. Okay, so here if we compare it with the standard form a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 equal to 0, if we compare it with that, we have a1 is equal to 2, b1 is equal to minus 3, c1 is equal to minus 7 and a2 is equal to k plus 1, b2 is equal to 1 minus 2k and c2 is equal to minus 5k minus 4. This. Now we have to find the value of k for which the system of equations has infinitely many solutions. So when does that happen? So what is the condition for that? Again, this is the questions are on conditions for solvability. So for infinitely many solutions, the condition is, okay, the condition for infinitely many solution is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So what do we need? We should have 2 by k plus 1 should be equal to minus 3 by 1 minus 2k should be equal to minus 7 by minus 5k minus 4. This is the condition. So let us take the first case where we have to find the value of k. So we can do it in three ways. So let's take the first comparison by equating 2 by k plus 1 with minus 3 by 1 minus 2k. So the first case, two by k plus 1 should be equal to minus 3 by 1 minus 2k, or 2 by k plus 1 is equal to 3 by 2k minus 1 by multiplying minus 1 in both the numerator and denominator. Okay, that implies 2 into cross multiplying 2 into 2k minus 1 is equal to 3 into k plus 1. That implies 4k minus 2 is equal to 3k plus 3. That implies 4k minus 3k is equal to 3 plus 2. That implies k is equal to 5. So we have got the value of k. K is equal to 5. Now this is by comparing the first two, a1 by a2 equals to b1 by b2. Now let us do the other thing, that is comparing this minus 3 by 1 minus 2k with minus 7 by 5k minus 4. Let us see whether we are getting the same answer or not. So we have case 2, where we have to compare minus 3 by 1 minus 3 by 1 minus 2k with minus 7 by minus 5k minus 4. Okay, so we can write it as multiplying minus 1 here, 3 by 2k minus 1 is equal to minus gets cancelled here, so 7 by 5k minus 4. That implies 3 into 5k minus 4 cross multiplying 7 into 2k minus 1. Okay, that implies 15k minus 12 is equal to 14k minus 7. That implies 15k minus 14k is equal to minus 7 plus 12. That implies k is equal to 5. So this way also we are getting k is equal to 5. Now let us do the other comparison, that is a1 by a2 is equal to c1 by c2. That is the third case. Let's see whether we are getting the same result or not. So case 3, where we compare 2 by k plus 1, that is a1 by a2 with c1 by c2. K plus 1 is equal to minus 7 by minus 5k minus 4, or 2 by k plus 1 is equal to 7 by 5k minus 4. Minus gets cancelled. That implies 2 into 5k minus 4 is equal to 7 into k plus 1. That implies 10k minus 8 is equal to 7k plus 7. Okay, that implies 10k minus 7k is equal to 7 plus 8. That implies 3k is equal to 15. That implies k is equal to 15 by 3, which is equal to 5. So this way also we have k is equal to 5. So either way you go, you will get the same result. So for k is equal to 5, the following system of linear equations will have infinitely many solutions. Okay, so no matter which way you compare, a1 by a2 with b1 by b2, a1 by a2 with c1 by c2, or b1 by b2 with c1 by c2, will get the same result, and you should be getting the same result. Okay, otherwise there is some mistake. So it's a good way to double check, triple check your answer. So it's a good thing. So this is the thing, for k is equal to 5, the following system of linear equations, it will have infinitely many solutions. Okay.